All right, so now we're going to look at the we do problems. Hopefully these weren't completely foreign to us and we were able to get most of them done independently. So 8 is a constant that's going to stick around. We're looking at the cosecant x derivative, which is negative cosecant x cotangent x. So my derivative here is negative 8 cosecant x tangent x. And then I have 6 to the x, which is the format a to the x. Remember my student last year said x Lena. You can remember it however you want, but it's going to continue with that 6 to x and then have a natural log 6 on the end. This guy, let's rewrite before we do we have to rewrite it before we can do the derivative. So a negative exponent will bring it up top. The radical with the 8, that 8th root, becomes the denominator of a fraction. So that's the same as saying negative 7/8. And then this one, the radical is the denominator, right? But cube root of 8 we know is 2. And we have x to the 2/3. Sorry, that 2 is hideous. That's slightly better. I'll take it. All right, then we do our derivative here, which is the power rule. Bring down your exponent. Multiply it times your coefficient. Make your exponent 1 smaller. Negative 15. And then those negatives bring us downtown. Sorry, I should have made my fraction bar longer. And there we have it. All right, last basic rule problem. We've got the derivative of natural log x, which is just 1 over x. And the derivative of log base 6x, which is going to be 1 over x natural log of that base 6. All right, now we get some product and quotient rules. Let's just remember, well, this is something you need to have on your mind, but product rules f prime times g, right, plus f times g prime. You have all those little x's in there. All right, so f of x here, 3/2 x to the 6. The derivative of that, 6 times 3/2, x to the 6 minus 1. So that would be 18/2, or 9, x to the 5th. Then g is tangent x. Whoopsie, might be. And the derivative of tangent x is secant squared x. So now we substitute into our rule. So our derivative with respect to x of this guy is going to be 9x to the 5th, f prime times g, tangent x, plus f of x, which is 3/2 x to the 6th, times g prime of x, secant squared x. And we're all set. Moving on down. So here we've got the same rule, f prime times g plus f times g prime. So f of x here, 3 sine x, g of x is cosine x, f prime x is sine, cosine, so 3 cosine x. And then we substitute in, so our derivative, f prime of x, 3 cosine x, times g of x cosine x, plus f prime of x, 3 sine x, and negative sine x. Right, and then this one's kind of different because we can rewrite it as cosine squared x, and then negative 3 sine x. That's a little bit special. All right, and then lastly, we've got a quotient rule. Our numerator is f. Should have given myself more space. And our denominator is g. And our equation is the same as the product rule, f prime g, except it's got the difference. And then it's divided by the denominator squared. So f prime of x here, derivative of tangent is secant squared, so we've got 2 secant squared. Derivative of a constant is 0, so the 3 just goes away. G prime of x, whenever we do the derivative of just coefficient x, the x goes away. All right, but in case you're still not on that train yet, here's the work for that. Because anything to the 0 is 1, so it's just going to be 2. Okay, so let's substitute in. We've got f prime, 2 secant squared x, times g, 2x, minus f, which is 2 tan x, plus 3, times g prime, which is 2, divided by 2xg, which is our g squared. So I've got 4x secant squared x minus 4 tan x minus 6 over 4x squared. All right, you'll notice the common factor in the numerator is 2. And then we've got 2, and that simplifies with the 4, right? That's a 1, and this is a 2. So our final answer is 2x secant squared x minus 2 tan x minus 3 divided by 2x squared. That's all, folks. Go ahead and try the you-do problems.